Hi everyone, today I will be giving a quick talk about our still ongoing journey about transitioning to clang-linker-wrapper from the legacy upload wrapper tool to support SYCL and parallel C++. In our SYCL implementation, besides support for CUDA and heap, we also support the various of Intel targets, and our main target for that is essentially SPIR-V format, which allows us to support just-in-time compilation, for example, and aim for various hardware. General flow is essentially the same as for CUDA and heap. We have some linker inputs, we extract device code out of them. We do kind of a full LTO where we link everything together, do some post-processing on it, and then we convert that to SPIR-V. We are using a SPIR-V LLVM translator standalone project, but we are also evaluating use of SPIR-V backend on that step. And then this resulting SPIR-V is being wrapped into the final executable, and this JIT path is actually a default for us, where we just bundle SPIR-V, so it is JIT compiled later when a kernel is invoked. Optionally, we can pass this SPIR-V to device compiler, which we call ahead of time compilation, and embed a native binary into the application. And here I will be talking mostly about the wrapping and post-processing step as something which maybe has more unique and interesting features which we have. So we started a while ago with clang-linker-wrapper. We just took what was there, and that is something we have ended up with, and that is something we currently have in our offload wrapper version. So one of the important design decisions we made is that we do not want to look into device code anywhere at runtime to understand if it is compatible with a certain device. We just want to treat it as a black box. We do not want to depend on potentially undocumented implementation details of third-party toolchain or some things. So we just embedded a few more fields to be able to understand kind of device image and which target it was compiled for. If it was an ahead-of-time compilation. One more thing which may be of interest is that we record compile and link options which were used for host application. So when we do JIT application, we could adjust the JIT compiler so it behaviors matches, for example, in optimization levels, the behavior of JIT compiler matches how host application was built. And of course, adding more and more fields is definitely not flexible. And even though we do have a version field to keep track of ABI, we came up with what we call device image properties. And essentially, each device image is accompanied by a list of property sets, where a property set is a named group of properties, kind of a namespace, and a property is a simple key-value pair from a string to either an integer or a byte array. We generate those properties from named metadata, which are left by various analysis passes in post-processing step. One of examples how those properties are used is optional kernel features. So in SYCL 2020, not every feature is expected to be supported on every device. For example, double data type is not required to be supported everywhere. And if a kernel which uses double is submitted to a device which doesn't support it, we need to throw a nice feature not supported exception in that case. And to do that without relying on parsing error logs from JIT compilation from a third-party backend, we instead have a pass which analyzes use of optional kernel features in all the kernels and records that information in a property set for us. So at runtime, we can just simply compare what this kernel uses, what device supports, and throw an exception if that is needed. So now that we come to clang-linker-wrapper, the question is, do we need to repeat all that changes and everything? At first glance, it seems like we do, because target device image is still the same tiny struct, and the documentation says that it just points to target device code. But in fact, it is not really true, because this image start, it points to some header, which contains actually all the information we need. It already has fields to distinguish different image kinds, different uploading kinds, and even has this string-to-string mapping, which is essentially an equivalent of device image mechanism we have. So for us, it seems like everything is almost already in place. Documentation, of course, could be improved because it took a bit of time to figure it out, all those extra details. And if we used lib on a PMP target infrastructure right now, we wouldn't actually be able to make use of all that extra information, because right now it is just being stripped off at the plugin layer, so it is not available to plugins. And that is something we will likely want to improve. Another, I think it's quite a unique thing we do in post-processing is called device code split. So let's say we have this SYCL application which tries to be portable, and before submitting kernels, it checks which features are actually supported by a device. And in this case, if both kernels were in a single device image, JIT compilation could fail because a certain kernel contains unsupported features and JIT backend just fails to accept that. So we split kernels into separate modules based on optional kernel features which they use. We do that, we support different methods of splitting per kernel, per source, and per optional features. And we do that for two main reasons. The first one is to be conformant with the SYCL 2020 specification to prevent so-called speculative compilation, where all kernels in a device image are compiled, even though not every one of them was actually invoked. And we also found that if you have a library which contains maybe hundreds of kernels which are specialized versions of an algorithm for different problem sizes and data types, you only expect the user to call just a few versions of those. And it's kind of a waste of time to JIT compile this whole huge library. So it could be beneficial to split it into smaller chunks to reduce JIT overhead here. And essentially, stay tuned. SYCL offloading kind is coming to clang-linker-wrapper at some point once we figure out all the details internally. And yeah, a couple of references for you if you want to learn more about our offloading and our upstreaming plan and everything. Find me around, I guess, for questions if you have any. Thanks.